And due to the relatively low rainfall, these habitats, this biome, is also fire adapted. So there are frequent droughts and periodic fires, as you see here. So the characteristic animals, the grazers that are feeding on this abundant resource of grasses are bison and pronghorn sheep in North America, wild horses and sheep in the Asian steppes, which you see here, and then even kangaroos in Australia and other grazers in South America. But if you have such an abundant resource of nutrients, grasses, there's going to be someone to come along to take advantage of that. And then, of course, you have the predatory animals that will take advantage of these herbivores, things like wolves and coyotes, and there used to be a North American lion, etc. So many of the birds nest on the ground because of the relatively scarcity of trees. A lot of small animals and rabbits and ground squirrels and gophers, they dig burrows to escape predators. And actually prairie dogs have elaborate colonies and underground burrow systems in these large grassland areas. So let's move on to temperate broadleaf forests, which are located in large parts of the world. So broadleaf trees, these are types of trees that tend to lose their leaves during the winter. So here's a picture of fall approaching, and the leaves turn color as they prepare to fall off of these trees. So these temperate broadleaf forests, they're throughout the mid-latitudes where there's sufficient moisture to support large tree growth. Precipitation, 30 to 60 inches per year on average. Temperatures do vary seasonally over a large range with relatively nice warm hot summers and relatively cold, even freezing winters. So in the northern hemisphere, I can do this. In the northern hemisphere, there's dense stands of deciduous trees that are typical of temperate forests. So deciduous trees are the trees that lose their leaves in the wintertime, and that's characteristic of many of the forests, especially in the northern hemisphere, in the Americas and in Europe. And that's different from what we see here, which are evergreen trees, which we'll get to next. So deciduous trees drop their leaves in preparation for winter because temperatures are too low for their photosynthesis to work efficiently. So their strategy is to drop their leaves, prevent evaporative water loss in the leaves from the summer, during the winter, when water is hard to obtain from the solid frozen ground, from the soil. So that's an adaptive solution to harsh, dry winter, is to lose your leaves and then grow new ones in the spring. Many mammals hibernate, and many bird species will migrate to warmer environments. Most of the original forests in North America and Europe have been cut and or cleared for lumber, agriculture, and urbanization development. So the North American forests do not look anything like they used to before human settlement altered the environment. So let's move on to coniferous forests. So conifers are evergreen trees. So if you think of your Christmas trees, those are coniferous trees, or evergreen trees, or sometimes called cone-bearing trees, gymnosperms. So the coniferous forests in North America are dominated by cone-bearing evergreen trees and include the northern broad areas of the northern coniferous forests, also called taiga. And these are the largest terrestrial biomes on Earth. And you can see they spread over a large region. One of the reasons why they are still so large is because these places have very cold winters, lots of snow. So they're places that are not easily inhabited by humans. So they haven't been that altered or destroyed or degraded by humans. And the reason there's a switch from deciduous trees to evergreens in the colder areas of these biomes is because coniferous evergreen trees are able to handle cold, harsh winters better than most of the deciduous trees. And the deciduous trees often tend to do better in the more drier climates. Here we go. So we do have temperate rainforests along the coast of North America, from Alaska all the way down to Oregon. And most of those are coniferous forest trees. And one of the reasons why they're temperate rainforests is because they're on the coast here, and they receive an abundant amount of moisture off the ocean. Okay, so moving further north, notice we've been migrating away from the equator in many of these biome systems. So way up north, we have the tundra. It's cold year-round, relatively very little precipitation, so much so that there's really no trees. So it's an expansive area of the Arctic between the taiga and the northern frozen polar ice caps. So the Arctic is the northern portion of the planet. The Antarctic is the South Pole. That's Antarctica that we see here. And that's all ice. So the tundra is characterized by what's called permafrost, where the soil is permanently frozen, even though that's changing a bit now with climate change. But anyway, historically, permafrost, fairly cold temperatures, high winds, and usually relatively little annual rainfall. Growing season is short in the summer, because again, we're so far north, so far away from the equator. Vegetation includes adapted small shrubs, grasses, mosses, and lichens that can handle this harsh environment. Okay, let's move on to water cycle. So we're not going to go through this entire chapter. It's relatively a long chapter. It easily could have been broken up into 2 chapters. So we're going to do the water cycle for sure. So all parts of the biosphere are linked by the global water cycle, because water is essential for life. And the nutrient cycles, because the water cycle, through erosion and movement of water through the soil, helps with cycling of nutrients through the environment. So water and air move in global patterns driven by solar energy. Remember, at the equator, solar radiation evaporates water, it rises, it cools, it drops a lot locally. The winds, because as the air rises, it has to get moved somewhere. It moves away from the source of initial evaporation. And at the equator, that means it's going north and south away from the equator. More locally here in this example, it's moving inland from the oceans, carrying moisture. As the air cools, it drops precipitation, rain, and the local habitats, in particular as we approach mountain ranges. So this is like analogous to California, and those would be the Sierra Nevadas, or the coastal mountain ranges. Okay? So solar energy is driving everything. The rotation of the planet also has an influence, as we mentioned before. So precipitation and evaporation are continuously moving water up into the atmosphere and then back down. Notice that water will also evaporate from land and also through what's called transpiration. That's water loss from plants during photosynthesis. And notice most of the evaporation is from the ocean. There's some precipitation, but there's a net flow of water vapor up into the air that forms the clouds, which carry that water from the oceans onto land. And by the way, that's fresh water. When salt water evaporates, the salt stays behind and only fresh, pure water goes up into the sky, into the clouds. Excuse me. So the water comes in from the ocean and then drops as precipitation on land. And on land, the precipitation is more than the evaporation and transpiration. So you have excess water on land. That originated in the oceans. So here we go. The ocean's evaporation exceeds precipitations. Cloud carry that moisture onto land. On land, the precipitation exceeds evaporation. The water will stay on the surface as snow or ice, lakes, ponds, or it will flow over the surface, streams, rivers, or it will percolate underground and form groundwater reservoirs, or percolate underground, eventually work its way back to the ocean, or rivers and streams that empty out into the ocean. And then the cycle begins anew. So human activities have affected the water cycle in numerous ways, like destruction of forests. So you have excess runoff, excess nutrient, soil, clouding lakes, and even creating low oxygen dead zones near the mouth of rivers and rivers and streams in extreme situations. Pumping of groundwater out for local use, which depletes groundwater resources. And then global warming, which affects the water cycle in complex ways and usually makes storms more fierce and or unpredictable, or changes rain patterns, causing more precipitation in areas or less precipitation in areas that are than is normally expected, causing all kinds of problems. And that is it for this chapter.